Hello, Algebra 1 students. Today we're going to be looking at some problems that should help you complete those first couple geometry review worksheets. Now I call them review even though this is Algebra 1 because this is some really basic geometry stuff which you should have seen before in middle school or some other environment, I hope at least. And if you haven't, I'm going to teach it from scratch in not a very exploratory fashion, but in kind of a here's how you do it fashion, okay? So this video is particularly for the problem-solving worksheet where you're working with area and perimeter formulas. So I thought first we review those formulas from middle school, some things you should have seen before. You've got to have these memorized going into something like the SAT or something like that. They're really basic. So you should have had them memorized already. If not, then memorize them now, yeah? So very basic stuff. So what if we've got a rectangle? I guess I'll just draw a simple little rectangle above here. And we'll call this the length and this the width. We want the area and perimeter formulas. What's the area of a rectangle? You guys know that. Right, so the area is going to be length times width, very easy. The perimeter, how do you figure out the perimeter? What does perimeter really even mean? It's the outside parts, right? So how many outside parts you got to add up for a rectangle? 4, and there's 2 length sides, right? So I'm just going to shortcut it and say 2 of those, and then there's 2 width sides. So I don't even think of that as something I need to memorize. It's like common sense if you know what perimeter means, right? But you might need that in a problem or two on this assignment. Okay, triangles. Triangles come in a wide variety of shapes, and there's actually a lot of different formulas that you can use on triangles. So the only ones that we should probably know by now are these. The perimeter of a triangle, if there's 3 sides, is going to be add up the 3 sides. That's common sense. I don't think you need to memorize that. It's just common sense, right? And there's lots of ways to compute the area of a triangle. The one you should know by now, though, is it's just like this. It's just like if you cut it in half, and let's say you're looking at that triangle, for instance, then the area is like length times width, but not all of it. It's just half of it. And usually we don't call length and width for a triangle. We call them base and height. I'll talk about why that is when we do an example. Okay? So I hope you've seen this before. If not, uber important. You forget this half, you're dead. So don't do that. Circle. The inside of a circle is pi times the radius squared. I think it's really easy to not mix this up with the circumference or perimeter of a circle, which is 2 pi times the radius. The way to not mix these up, but you need to have these both memorized, probably the most important ones besides this one on this list to have memorized, is that this one has a squared in it already, and aren't the units of any area you find squared units? So it's really easy not to mix that up if you think for a second. This one doesn't have a squared, it's just r, which is just like how long something is, which is perimeter, okay? But if you've never seen those before, I don't know what to say, now you've seen them. So let's use them to solve a couple simple problems. So we've got what kind of shapes for number 1, obviously? Circle. Circle, and I didn't tell you whether that's a rectangle or a square. But if it's truly inscribed, that's the way you describe this, it's inscribed inside of the rectangle square thing. If it's truly touching all the edges, doesn't this have to be a square? Yeah, I think it's got to be a square. So assuming that I'm drawing it correctly and that it's truly touching the edges and that it's truly a circle and not an oval, then I think it's a square. Okay? So what do you guys guess this problem might be asking based on just looking at it with no directions? What might it be asking you to do? It's got something shaded, right? I'm guessing they want you to figure out the what of the shaded part. Area, right? Okay. So how are we going to do that? We've got 2 different shapes, one's inside of another. We just want the shaded part in black. I think the strategy here is take the outside shape and subtract the inside blank part. Does that make sense? And what you'll be left with is the black part. So it's not real hard, but that's the way most of your problems on this worksheet will work. Some of them are simpler than that even, but okay. So the outside shape is square, which is a kind of rectangle. So what's the outside area? So I'm going to say area outside is 8 times 8, so 64. And it's an area, so I want to say square inches, right? Make sure you get your units correct on these. Okay, the inside is a circle, so the area of the inside, and you know, this isn't specific, I'm just trying to make it make sense. That's why I'm subscripting it with O for outside and I for inside. That's just smart. It's not essential. Okay? So inside is a circle, and you've got the formula right over there, right? So we're going to go pi times the radius. Ooh, what's the radius of this circle? Does it like jump out at you? No, I think, but you've got to think for like a second. The radius is like this, right? But couldn't you think of that like right here pretty much too?
Yeah.
So the radius is
4 inches.
4, right? So we're going to say pi times 4 squared, right? And I think it says use 3.14. You guys have a calculator though, so use your calculator to get something like that. So here, let me stick my calculator up on the board really fast. And there's a pi button on there to get it just right. So we're going to have 4. Something's been messing with my calculator maybe. Oh no, just Holloway was using it and stuff. Okay, so pi times 4 squared, or pi times 16, right? And so that's what we get for that one. Does it make sense that it's smaller than the outside?
Yes.
Yeah, if you got something bigger, you should be like, oh, I did something wrong. Correct? So the area that's shaded isn't this number or this number, it's
Whatever you get from
the subtraction, right? So we're going to go 64 minus, and really I have that other answer still stored as the last one, so I think I can just hit second answer, and that's the nicest way. So that's what my answer is here. I'll write it in red. So the answer here is 13.73, and if they don't say it around, I'm just going to go out to the third spot always. So 13.734, 13.735. And my units, this is area perimeter, it's area, so inches squared, because it's how much it takes to cover up, how many square inches it takes to cover up this black area. Total is 13. Okay? Is this making sense? Any questions so far? Okay, sweet. So let's go on and look at another example. This time we've got a triangle. I don't see anything about shadedness, so I'm guessing they're probably just asking me what's the area of this triangle. We'll find the perimeter too. Let's do the perimeter first. That's usually easier. So perimeter of this triangle, I could call it T for triangle, but it's pretty self-explanatory. So there's like a solid triangle, and then I have like some virtual dashed lines as well. I wonder why I have those. Well, they add a little bit of complication, but they're also there for a reason. So what numbers am I going to add up to figure out this triangle's perimeter, how long it is on the edges?
7, 10, and 17.
Yes, only 3 of them, right? 7, 10, and 17. Why not 6?
Because it's not part of the triangle.
It's not part of the actual triangle. This is like part of this like virtual projection, right? So I'm going to say this is a solid edge, this is a solid edge, and that big one's a solid edge, the hypotenuse type thing. Yeah. So it looks like we have 17 and 17. I think that's 34. Now, I want my units correct here, right? So is it centimeters or centimeters squared?
Centimeters.
Centimeters, not square centimeters. This is how long it takes on the outside if you were like to put it all in one line, right? That's what perimeter means. So that was pretty easy, I think, at least. Hopefully you guys agree. So how about the area of this guy? Again, we're going to have to subtract something because there's not 2 shapes here. If you're like, well, there's 2 shapes, Mr. McGee, remember, this is just a virtual projection. So I should start by thinking, okay, what's the formula? I could go over here, right?
Yeah.
So what formula am I going to use for the area of a triangle?
1/2 base times height.
Yes. So that's where you start, write out the formula, right? And you say, well, half is half. There's nothing to plug in there, it's not a variable. And what's the base of this triangle? So now you got to think, It is 7, good choice, guys. So why is it 7 and not like 12?
Why would it?
Why would it be
Not even
12?
on the triangle.
I think 12 would be another possible choice.
Why?
Where's my 12 coming from?
6 and 5.
I was adding 7 and 5, right? Like this whole thing. How come I'm not calling this the whole base?
Because
It's not part of the-
It's not actually like the base of the physical triangle, right? We're trying to think about how many square units it takes to fill up this triangle like so, right? Except for being smart about it instead of trying to draw a bunch of equally sized squares, especially since mine are obviously not equally sized because I'm such a great artist, right? So I think that's the actual physical base. That's what you got to use, right? So why did I have these dashed lines in here at all?
To figure out
The height, what's the height?
6
6. How come it's not 17? Doesn't this go from the top, or like the bottom to the top? I'm thinking like upside down, but
I don't know.
It's not the height.
that's not the height. That's like a slanty thing. The height is like how tall it is. How tall it is this. If you flipped it over, it would be like this, right? But like, that's the height, even though it's like going down. So that's the reason I had that projection stuff on there, okay? So when you see something like that, you're not going to use all the numbers. You just got to think about which ones you need for the base and height, for instance. And then you're done, right? Like, this is easy. So think smart here. I don't need a calculator to do this. Half of 7. If you're like, I'm going to do half of 7 first, you're not being strategic. You're being lazy.
7 times 6.
It's half of what?
42.
If you go 42, that's good. That's better. But there's a better choice here, too.
Half of 6.
I'm just thinking basic math skills. Like, be smart. Half of... Can't I go half of 6 when it's all multiplied 2? That's easier. What's half of 6?
3.
So then you have 3 times 7. That's a much smarter way to do little things like that. If you've never thought like that, start doing it. You'll get better and stuff. My units. I need units, right?
Centimeters. Or squares.
Centimeters squared, right? If we were doing volume, we might have cubic centimeters. Okay, so I'm going to erase this stuff to get it out of the way. My other example up here is pretty small, so sorry about that if you're watching the video and having trouble seeing. So I think I mentioned how to describe this with a certain vocabulary term a second ago. Can anybody? Yes, very nice. Inscribed. Perfect. So how could you describe this using that word? What do we have here?
Yeah.
So how do we say this again? My class just said that the term I used earlier that would be useful is inscribed, and I think they're correct. We have a circle, we have a pentagon. Which one's inside of which? So we have a pentagon inscribed in a circle. Very nice. That's how you'd say it. And that's not what the main point of this lesson is, but that vocabulary is all good. So we want the shaded area again. I think it's just like that other one, except this one's a little bit tougher. Okay? So I'm going to draw it bigger over here just so you can get the idea. My art is just going to be fantastically amazing. So I think I was trying to draw a very equally sided pentagon. I think I did a better job there than here. But the only way it's actually going to be inscribed in a perfect circle is if all the sides of the pentagon are perfectly the same size. Does that make sense?
Yeah.
I don't think it would work otherwise, like something will pop out the edge. So we can assume over here on the pentagon that all the sides are the same. This is how you mark that with geometry. It's like a little tick thing, like my orange. Okay? So I think we need that assumption to solve this problem. Finding the area of the outside is going to be easy. How are we going to do that? I heard it already. Use a circle. So it's one of these. Which one? I don't want the length around the edge. And it might ask you on some problems. I want like how much it takes to fill that up totally, ignoring the pentagon. So it's going to be pi r squared again. Right? So then we say, okay, what's the radius of this circle?
4 centimeters.
I think it's the 4. How come you didn't pick the 3?
Because, that's weird.
You're right. No, you're totally right. You picked this one, right, Dylan?
Uh-huh.
It's because it went out to the very edge, right? The other one like stopped right here.
Yeah.
You can't see it very well in my small picture.
Exactly.
So you're right. Very nice. So this is 4. So I think this is like the same size of circle we had a second ago, even if I kind of didn't draw it to scale. So didn't we have that as like 50, you guys have it in your notes? 50.265, thank you so much. Centimeters squared. Okay, so the outside was super simple. It's the inside that's going to be tricky. Subtracting them won't be hard either. It's just the inside that's the only thing. How do I figure out the area of a pentagon? Did I put it in our basic shapes list?
No.
Well, that's because each pentagon is different, and it's not super easy to figure out any random old pentagon. But something was special about this pentagon. What was it?
All the sides are the same.
Okay, so that means you can apply not crazy creative, but somewhat creative strategy. If they're all the same size, what could you do with this pentagon?
We just need
You
to
can
find
add
the
a
side.
rectangle.
Do we just need to find one?
Rectangle's not the basic shape here. There's another basic shape, one of the 3.
Triangle.
Where?
If you go, yeah, that works. Yep.
How many?
5.
And if it's technically a regular same-sided pentagon, then those are each the same size, so we can just find 1 and multiply by
5.
5. So the strategy here will be take the area of a triangle, which is half base times height, and multiply that by 5 to get the inside total. Does that make sense? I don't think it's rocket science. It's a little more creative though. So we're going to say, okay, what's the base and height of our triangle? So then you got to look carefully over here. So I had like, I'll use red. I had a little dot, dot, dot right here that said this was 3, and I had like this side over, this piece over here was 4. So I think we should pick one triangle and just focus on that. Those look like they're in 2 different triangles, right? So I'm going to just get rid of the 4. Let's focus on this triangle, shall we?
Okay.
So the 3 is the what of the triangle? The height? What's the base of the triangle?
3.
1.5.
It's trickier. It might be the 4, right? So if the 4 was this, right, if it was the radius all the way out to the edge of the circle, where does the 4 go on this red triangle? I think it could go on one of either of these sides. I mean, I know my triangle's kind of gimpy, but you have to bear with me. So if that's 4 and that's 3, I don't think this is the base of the triangle. Do you guys?
No.
So I'm going to blow up that triangle over here. Here it goes. Try to draw it a little nicer. It's the same triangle, right? There's 3, and this is 4. I need this, do I not? So somehow, and on your problems, it'll be a lot easier to figure this out, like I just gave it to you if you look at it right. But I'm doing something a little bit into the future on this one to show you other stuff you need to know as we go on, okay? So I doubt any of yours will be this tricky. But, so we have 4 here, 3 here. We just need this. Well, not real sure how big that is. I think we know this is a right angle though, right? And you know what? I think I can just cut this triangle off in half if I really want to. So this is going to be pretty short down here, right? How can I figure it out if that's a right triangle? This should be something you learned in middle school as well. And you might not need it on this worksheet, but you're going to very soon. We're going to use it a lot.
Isn't it like the c squared minus a squared equals b squared? Or?
Yes.
I'm so smart.
So this is Pythagoras. So here's the first time this year you're going to use Pythagoras. We're going to use it a lot more times. So I think 3 is 3A, B, or C.
3
3
is
is A.
3 I think could be A or B. So let's just put it in for A like you guys said.
Alright.
And is 4 A, B, or C?
B.
4 is across from here, so it has to be C.
Yeah.
And just hang in there for a second. So then you solve for B. So I'm going to subtract 16 minus 9 is what, 7? And then I'm going to square root both sides to get rid of the squared like this. So this is the square root of 7. So to finish this problem, and yours will be easier than this, okay? But to finish this problem, I'd have to put this together and say, okay, so hang out, finish this up, you're not dismissed. So the height we said was 3, we had the 5 for the 5 triangles. The base, is it just the square root of 7? Remember, that's just this half. I want the whole thing. So it's double the square root of 7. And whatever this comes out to is the area of the inside. So let's just say this comes out to, you know what, let's just do it. We need to take our time here. So I'm going to go half times 2 times the square root of 7. And I'm going to just multiply that by 15, right? 3 times 5. So that's 39.686. So then what do I need to do last? I've got the outside, I've got the inside, I've got to subtract. And it makes sense that this is smaller, right?
Yes.
And not too much smaller because there's just a little bit out there. So it's going to be about 11. Okay? So I won't subtract that. I think you get the idea. So for anyone watching the video, I don't think you're going to get into Pythagoras yet, but you might. Most likely you're just going to have to look at the triangles carefully when you chop it up. I'll see you next time.